This is example 8-5, where we're going to look at a dimensional analysis of capillary rise. All right, so we have a capillary tube that's sticking in some kind of a liquid or in some kind of fluid, and we can observe that it rises at up to a level of h, a height of h, and we'll assume that all this depends on the diameter, the surface tension of the fluid, the density of the fluid, and the gravitational acceleration. And we're asked to find out what the relationship between these parameters is, and then we're supposed to plot the relationship between the two pi terms that we get. But let's start with our variables, right? So we'd have f of h and d and sigma and rho and g. That is equal to 0. So that means we have 1, 2, 3, 4, 5 variables. Which means that n is equal to 5. So what are they? They are h, which is a length, d is another length, the surface tension is mass times t to the minus 2. Then we have density, which is a mass divided by volume, so L to the minus 3. And then g is the acceleration, so it would be a length times or divided by t squared. So there we have our 1, 2, 3, 4, 5 variables. Now we choose the 3 variables, or let's write this down first. So we have all 3 primary ones, so 3 primary dimensions. Three primary dimensions means m is equal to 3. Then we get n minus m is equal to 5 minus 3, means 2 pi terms. All right, so now which ones do we choose to use as our repeating ones? So we need to make sure that all 3 of our primary dimensions are in there. So we couldn't, for instance, choose h, d, and g because we didn't have mass in them. So maybe we'll leave out h, right? And then h and maybe sigma. Right, if we leave out h and sigma, right, then we have a length, we have mass, and we have time. Yeah, so that should work. So let's start the first one with h. So with h, right, so we'd have pi 1 is equal to d to the a, rho to the b, g to the c, and then h. So if we write that in dimensions, then L, of course, is just a length, or D, I'm sorry, is just a length. Then rho is mass per length cubed, raised to the b, and then we get the acceleration, so length per time squared, that is c, and then h is just another L. All right, so then we'd have m is raised to the b power. Then L has a bunch, so that would be a, right there, minus 3b, minus 3b, then we have L, so we have c, plus 1 for the last L, and then for t, where do we have? We only have one t, so we minus 2c. All right. So that means we can find get our three equations. Right? We get one for m. Our m equation is 0 is equal to b. We get equation for L, so L would be equal to a minus 3b plus c plus 1. And then t would be 0 is equal to minus 2c. All right, so that makes it easy. B and c are 0. Right, so we can say b is equal to c is equal to 0. If that's the case, then a, if those are all 0, a is b minus 1. A is equal to minus 1. That means our pi 1 term would be d to the minus 1, that was our a, rho to the 0, g to the 0, and h. So basically we get h over d. That's a good start. Nice and compact. So now let's do the same thing. You're running out of space. Let's squish this a little bit in here. So with sigma, right, we'd get pi 2 would then be d to the a, rho to the b, g to the c, and then sigma. So we get L to the a, ml to the minus 3. Let's write this a little clearer. Minus 3. And then to the b power, of course. And then g was just length per time minus 2. C, and then sigma is mass t to the minus 2. So that means we get m is b and plus 1 right back here. Then L, we get a minus 3b plus c, and t is not equal to, t is minus 2c minus 2. Then we can find our three equations. Would be our m equation is 0 is equal to b plus 1. Our L equation is a minus 3b plus c, and our t equation is minus 2c minus 2. Oops, forgot that equal to 0. Both of these. That means b is equal to minus 1. We can find from the last one that c is also minus 1. And then we can find that a is equal to minus 2. All right, so that means for our pi 2 term, pi 2 is going to be d to the minus 2, rho to the minus 1, g to the minus 1, and sigma. So sigma over d squared rho g. And then let's squish that in the end here. So we get f h over d and sigma of d squared rho g is equal to 0. All right, so now we have kind of the overall shape. So what we can do is we can go back up here and we can take this data and we can use the h and the d to find out what our two where are we? Our two values are here, right? For each data point in that table. Now to do that, we'll have to figure out what sigma is and what the density are. But we can get that from the temperature we're given here, temperature of 20 degrees C. So if we do that, then we can create this table right here with these two values, right? This is just plugging in the values from the table that we have here, so h and d. And once we do that, we can plot those values, right? We're plotting h over d versus rho over sigma over rho d squared g. And then we get this nice straight line. Now, if we have a nice straight line, right, we can of course think we can describe this. We can say y is equal to mx plus b. We can kind of see that this goes through the 0, so we can say this will be y is equal to mx. Now, if we look at this graph, right, so we can say, well, y is up here, x is down here, right? So we can say, if I choose a y value, for instance, this 40, right, so we can say 40 is equal to, well, 40 right there leads to 20 down here. So it should be m times 20. That means m is equal to 2. All right, so from that, going back to my y is equal to mx, right? So I can say y is equal to 2x. In my case, y was h over d, and x was sigma over rho g d squared. And if I now solve that for h, right, then I get 2 sigma divided by rho, that's not a rho, rho g, and then if I multiply by d, then I'm only left with d. And of course, if you remember back to the beginning of the semester, this is exactly what we'd found for the capillary rise, if the tube is standing straight up, which in this case it is. All right, so that's this is what we get, exactly what we expect, just using dimensional analysis and then doing measurements. In the book, right, we saw we can derive this equation, but in this case we now found it through experiments.